Alright, so an awesome intro to LEDs, and we actually have a fancy LED for you guys. You should have a couple of them in your goodie bag of electronics, and these are called RGB LEDs, red, green, blue LEDs, because they have the capability of emitting those three different colors individually, and you can also mix them by pulsing red, green, and blue to get pretty much any color you want out of these LEDs. So that's kind of cool. So here in the wiring diagram, you can see we've got the RGB LED with 4 legs there, and you're gonna have to look and see on yours. But the longest leg is the ground leg. Okay. So what I did is I have got I didn't change this resistance yet. I'm gonna make this a 330 ohm resistor, orange, brown, and so I'm going to hang a resistor off of the ground pin. So remember, the longest leg goes in here. I'm going to hang a resistor off of that, and that's going to go into ground, right? And then each of these pins, red, green, and blue, whichever they may be, I don't know if these are actually how it is ordered, but I'm going to plug them into pins 3, 4, and 5, just for an example program. Okay? Very, very simple wiring diagram. So let's go over here. I guess we can, no, it's not even worth leaving, right? Let's go ahead and write up a program to light these guys up. Okay? Really, really basic. So remember, the first thing we got to do is when we want to write to LEDs, or I'm sorry, write to our output ports, output pins, we need to specify the pin mode of each of them, and in this case they're going to be outputs. Hopefully we can get to inputs at some point in this camp. That would be fun as well. But there's no rush. Pin mode, so 3, 4, and 5 all need to be initialized as outputs, right? Good. Now let me just clean that up. And let's make this puppy loop over and over again, just you know, because we're gonna have like a discotheque thing going on, gonna rave. So we've got our outputs. Now let's just go ahead and say digital write. Remember how to do digital write. So we're gonna turn these pins on. Oh, I spelled it wrong. Digital write. We want to turn this pin on, pin 3 on, to make our LED turn on. And we're going to delay for, you know, we want to flash these LEDs, so we're going to delay for a little bit of time. And then I like to just copy it, and we'll just say low, because we want to turn it on and off real quick. And that's, remember, this is 50 milliseconds, right? Remember these predefined functions, the argument for delay is in milliseconds. So we're going to give it 50 milliseconds, and that's going to turn on and off. And then we're going to go down and say, do this, you know, 2 more times. 3, and let's do this for pins 4 and 5. Right? That should be it, right? Alright, so as you can see here, I've got the same wiring scheme that I had in the schematic going. Here's our LED. Our ground is hooked up with the resistor, the 330 ohm resistor, and that's going to ground over in the Arduino here. And we've got each of our red, green, and blue you know, output pins going to the LED. So let's go ahead and upload this guy. I'm going to plug the Arduino in. Oh wait, you know what? I might still have the code on there. No, I don't. Okay, good. Let's upload it and see what we got. Can you see okay? Alright. This is going to be, yeah, it's really bright. So I'll cover with my fingers so you get the idea, right? You see the red, green, and blue flashing in great succession. Alright, now you might be thinking, we just did all this for loop stuff, all these looping things, and now, okay, so we're using void loop to our advantage, right? So that does definitely help us not have to use a loop, but we could definitely cut down the size of our code by 2/3, right? And so how are we going to do that? Well, we can write a for loop, right? So let's say for, and so we don't, okay, so we don't want to initialize, well, okay, so for now, let's just do it this way. Int x equals 3. X is less than, what does it need to be less than? Let's say 6, right? Because we want to get our 5 to run, because remember our pins are 3 through 5, 3, 4, and 5. So things, and then x plus plus, and then we're going to run this, oh, where do we go here? We want to run this block of code, and instead of 3, we want it to be x, right? So the only thing I don't like about this program is that the void, so loop is going to happen, or we're going to enter our main void loop. This for loop is going to happen for x is 3, good, pin 3, 4, it's going to do it because it's an increment, and then 5, and then increments to 6, and then quits out, right? So it's not going to do digital writing for 6. So this is good, and then loop is, remember, loop is continually going, so the for loop is actually just going to keep running again, running over and over. The thing I don't like is that we're initializing x every time. So maybe what would be better is say up here in x equals 3, you could say x right here, and then once you get down to the bottom here, do something like that, right? So this is going to accomplish the same thing. To me, it seems more efficient because you initialize your value, you initialize x one time, and then you recycle it for x. So x starts at 3, you increment it, boom, and then once, remember, it's sequential. After this for loop executes, you're going to come down and finish the rest of your program, which we're going to add in this x equals 3, and then once it gets back to the top of the for loop, or once it gets back to the top of loop, you know, it just keeps running this over and over again. Once it gets back here, x is going to be equal to 3 again. So we're going to get the exact same scenario. So this is actually, I think, a little bit more efficient way of doing that. So let's go ahead and test this guy. So here we go. Let's plug her in and upload this new code and see what happens. Right? Okay, so this is the old code still running. Boom, it's uploading, and there you go. Same old, same old. And if you really want, we can change, just for proof of concept, let's just change the delay time. Let's go with half a second here. Remember, it's in milliseconds. Oh my goodness, that is bright, isn't it? Yeah, let's see what happens. Increase the delay by a factor of 10 on each. Oh, there you go. Wow, that is so bright. We might not be using the right resistance for this, boys and girls. So we'll have to talk to some senior mentors and see if we're using the right one. Because I don't want to burn out the LEDs. That would be bad. And remember that LEDs are polar. And polar, from what we talked about earlier, means that you have to pass current through one way. And if you remember from the talk about the depletion region, if you apply current in the wrong direction, you increase the width of the depletion region and causes no current to flow. But if you apply it the right direction, the electrons flow because the N-type junction that is doped with something with extra electrons is going to flow electrons into the P-type with the vacancies in it, and that will establish a flowing charges and thus current, right? So LEDs must be wired up properly. They are polar. That about does it for looping, and for a little example with the for loop there. We've got our LEDs going. The last little application of the LEDs before moving on to some really fun stuff is going to be I'm going to show you how to do some PWM, pulse width modulation, and that will lead us in to finally the moment you've all been waiting for, driving around some robots. So bear with me on this one last lesson, and we will finally be getting to the robot part. Alright, I'll see you in the next video.
Great success!